Howdy everyone, welcome back. Today's lesson is going to focus on copy semantics, specifically looking at the default copy mechanisms that is provided to us by the compiler for objects of user-defined type, as well as ways how we can implement our own copy policy for our user-defined types. Today's lesson is going to begin with a just discussion about what is the default behavior when you say initialize one object of user-defined type with another of the same type of object. Likewise, what does it mean to assign, say, an object of your user-defined type to one of the same type? So we'll go ahead and get into that at the beginning. We'll then transition into a brief discussion into the differences between shallow copy and deep copy. We'll define what those terminology means, and we'll see that the default copy semantics essentially afford a shallow copy, and in many instances when our classes own, say, dynamic memory or a resource, what's known as a deep copy policy may be better. So in order to accommodate those instances, we will get into implementing a deep copy policy for our user-defined types, and we'll close out the lesson with a brief discussion about our introduction to the rule of 0 in C++, as well as the rule of 3. But before we get into these, I want to go ahead and just take a brief aside and discuss the destructors' responsibilities, because this will come into play in today's lesson. So the destructor is going to be responsible for freeing any resources that belong to an object. So this might be dynamic memory, closing a file, etc. Before an activations record is removed from the stack, so before, say, named objects are going to have their memory deallocated for, the destruction process will proceed as follows. We're first going to call our object's destructor. Then we'll begin removing the actual objects that reside within our activation record. So this would be calling the destructor functions for, say, our standard library vector. If an object of that type is owned by our class, the destructor for string. And then we spoke about how, well, at the end of this, when we successfully return from a function, that stack pointer gets moved down. And at that point, essentially, the objects such as the primitive types or the memory residing in an activation record for a user-defined type would be deallocated at that point. So with that in mind, let's go ahead and move into our first topic, default copy semantics and user-defined types.